Let me do a tutorial to find the line integral of a surface. Example. Evaluate f sub c of vector f dot product dr. If vector f equals to x squared plus y squared into I minus 2x times yj, which is a rectangular area located in xy plane from x equals to minus a to x equals to plus a and y equals to 0 to y equals to b. The question says that there is a rectangular area which is located in xy plane with a range from x equals to minus a to x equals to plus a and y equals to 0 to y equals to b. So I'm gonna find the line integral of that surface. Solution. The formula of the line integral is here, which is integral sub c of vector f dot product dr. Since the rectangular area is located in xy plane, so let me draw x-axis and y-axis. This is xy plane. Now in the given equation, I can see that it ranges from minus a to plus a. And therefore, I'm going to extend the x-axis to the left side to have minus x. And also extend the y-axis to have minus y. Let me draw the rectangular area and name this point A with coordinates minus a, 0, where x equals to minus a, y equals to 0. Name this point B with the coordinates a, 0. Name this point C with the coordinates a, b, x equals to a and y equals to b. And name the fourth point D with the coordinates minus a, b, where x equals to minus a, y equals to b. Now I'm going to find the line integral of this surface. Look at here. At the x-axis, the rectangular ranges from x equals to minus a to x equals to plus a. And along y-axis, it ranges from y equals to 0 to y equals to b. So I'm going to find the line integral. And the formula of the line integral is here, integral sub c of vector f dot product dr, where c stands for the curve of a surface. Curve of a surface, line of a surface, outer boundary of a surface. This is one thing. Since the given rectangular area has 4 sides, therefore I'm gonna make 4 terms: c sub 1, c sub 2, c sub 3, and c sub 4. Let me name this side C1. C1 is the curve 1, or side 1, or boundary 1, where y equals to 0. Now take derivative of y equals to 0 on both sides to have dy equals to 0. Name this side C2. Take derivative of x equals to a on both sides to have dx equals to 0. And name this side where y equals to b. Take derivative of y equals to b on both sides to have dy equals to 0. And finally name this side C4, where x equals to minus a. Take derivative on both sides of x equals to minus a to have dx equals to 0. Since we have discussed in introduction that line integral process takes place in anti-clockwise direction, let me start from C1, and then C2, and then C3, and then C4. So it goes in anti-clockwise direction, and then we'll add them together to have a final value of line integral. Limits along C1. C1 is here, which is on x-axis. So the limits will be ranged from x equals to minus a to x equals to a. And limits along C2. C2 is here, which is along y-axis. It ranges from y equals to 0 to y equals to b. Limits along C3. C3 is also along x-axis. So it ranges from x equals to a to x equals to minus a. It goes in anti-clockwise direction. And limits along C4. C4 is here, which is along y-axis. Ranges from y equals to b to y equals to 0. First, let me find the dot product of vector f and dr, where vector f is here, which is x squared plus y squared into I minus 2x times yj. And dr is obviously dxi plus dyj plus dzk. Take their dot products. When I take the dot product between these two terms, I times I equals to 1. And dot product between these two terms, we are j times j equals to 1. Since the rectangular area is in xy plane, So we have nothing to do with the z-axis because the rectangular area lies in xy plane, not in z. So just cancel the z. Finally, I have x squared plus y squared dx minus 2x times y dy. This is the final value of dot product of vector f and dr. Now the next thing that I'm gonna do is to take the integration on each side. Start it from C1, where y equals to 0 and dy equals to 0. Just substitute the value of y equals to 0 and dy equals to 0 in this equation to have finally x squared dx. Now take integration on both sides. Limits along C1 are x equals to minus a to x equals to a. Now take integration on both sides. Integration of vector f dot product dr, which is integral sub C1 of vector f dot product dr. And also take integration on these sides with the limits x equals to minus a to x equals to a. Now take the integration of x squared to have x cubed over 3. Distribute the limits and finally I have 2a cubed over 3. This is the final value for curve 1. Just put 2a cubed over 3 under C1 here. Just put it here. Now start from C2, where x equals to a and dx equals to 0. Substitute the value of x equals to a and dx equals to 0 in this equation to have finally minus 2ay dy. Limits along C2 are y equals to 0 to y equals to b. Take integration on both sides. The integration of this term is actually the integration of C2. Then also take integration on the right sides with the limits y equals to 0 to y equals to b. Integrate 2ay with respect to dy to have minus 2ay squared over 2. Distribute the limits and finally I have the value minus a times b squared for C2. This is the final value for C2. Just put minus a times b squared under C2. Just put it here. Now take C3, where y equals to b and dy equals to 0. Substitute the value of y equals to b and dy equals to 0 in this equation to have x squared plus b squared dx. The limits along C3 are x equals to a to x equals to minus a. Take integration on both sides. Integration of this term is actually the integration of C3. And take integration on the right sides with the limits x equals to a to x equals to minus a. Take integration of x squared plus b squared to have x cubed over 3 plus b squared x. Distribute the limits to finally have the value minus 2a cubed over 3 minus 2a times b squared. This is the final value for C3. Just put this value under C3 here. Put it here. Now take C4, where x equals to minus a and dx equals to 0. Just substitute the value of x equals to minus a and dx equals to 0 in this equation to have minus 2ay dy. Limits along C4s are y equals to b to y equals to 0. Take integration on both sides. The integration of this term is actually the integration of C4. And also take integration on the right sides with the limits y equals to b to y equals to 0. Take integration of 2ay with respect to y to have 2a times y squared over 2. Distribute the limits to finally have minus a times b squared. This is the final value of C4. Just put this value under C4 here. Minus a times b squared. Now I got all the values for C1, C2, C3 and C4. Let me add them to have the final value, which is minus 4ab squared. This is the final value of line integral for that rectangular area.